In this example, we're given the equation for a supply curve, which tells us that the supply price is equal to 10 plus 3 times the quantity supplied. And we're given the equation for a demand curve, which tells us that the demand price is equal to 30 minus 2 times the quantity demanded. So let's begin by graphing the supply and demand curve for this market. So here we have the quantity on the x-axis, the price on the y-axis. The supply curve begins with a y-intercept of 10 and a slope of positive 3. So we begin here at 10 for our y-intercept, and then the supply curve slopes upward. Okay, for the demand curve, we begin at an intercept of 30, and then we have a slope of negative 2. So 30 is our y-intercept for the demand curve, and then our slope is negative 2. Okay, and we know right off the bat that there's going to be an equilibrium where the supply and demand intersect. And our first task is to actually find what the numbers are for P star and Q star. So there's two ways we can approach this. One is that we can set the equation for supply equal to the equation for demand, and then solve for Q star and P star. The other is to plug in different values for Q in both the demand and supply equations and see at what quantity, that is, at where's Q star, at what number that we plug in into both of these will spit out the exact same price, that is P star. So let's start with the first method. Okay, so the first method we would set supply equal to demand. So the supply curve, and I'll call that Q, instead of quantity supplied, I'll call it Q star because that's what we're solving for when we set supply equal to demand. The demand curve is 30 minus 2 times the quantity, and again we put Q star there. So solving this, we get 5Q star equals 20, or Q star equals, both sides divided by 5 gives us Q star equal to 4. And then we plug in to either the supply or the demand equations to get P star. So I'm going to plug into the demand equation, but you can use either. You should get the same answer regardless. So 30 minus 2 times the quantity of 4 gives us a equilibrium price of, let's see, 30 minus 8 is 22. So $22 is our equilibrium price, and 4 is our equilibrium quantity. Right, so the other way we can do that is by solving for, or rather plugging in different values for the supply and the demand curves. So let's set up a little chart here for different quantities. We'll see what is the supply price and what is the demand price. Okay, so for a quantity of 0, plugging that into the supply curve, we would get 10 plus 0 is 10. Okay, plugging it into the demand curve, we would get 2 times 0, 30 minus 0 is 30. So let's add that to our table here. So 10 versus 30. Okay, if we plugged in 1 for the quantity, the supply curve would give us a supply price of 13, and the demand curve would give us, let's see, 30 minus 2 would be 28. Okay, so far we have not found a quantity at which the supply price and the demand price will match. So let's keep going. 2 plugged into the supply equation would be 10 plus 6 is 16. Plugging 2 into the demand curve, 30 minus 4 is 26. All right, we still don't have a match, so let's go to 3. And by the way, we should know that we won't have a match until we get to a quantity of 4 because we already solved the answer, which is 4. All right, so going back to our table here, plugging in 3 to the supply curve would give us 19. Plugging 3 into the demand curve would give us 24. Still no match, and then we should get a match once we get to 4. 10 plus 12 would be 22, and the demand curve 30 minus 8 would be 22. All right, so we finally have our match at a quantity of 4. Both the supply price and the demand price are 22, right? So at a quantity of 4, both the supply price and the demand price are 22. So that's our equilibrium. All right, the next part of the question asks us to calculate or figure out what would happen if instead of the market clearing price of $22, if the price was set lower than that at $20, what would be the impact on the market? Well, let's see. The price of $20 would hit the supply curve right here. So the quantity supplied would be lower than 4. And $20 would hit the demand curve right here. So the quantity demanded would be higher. Okay, so we would have a shortage, right? Demand is higher than supply. So we would have a shortage of the product. And now the question is, how much of a shortage? So we can calculate what QS would be, okay, by plugging into the supply curve. So we plug in $20 for the supply price, write out the rest of the equation for the supply curve, and then we can solve for QS. So we get 10 equals 3 QS. QS, divide both sides by 3, we get 10/3 or 3 1/3. Right, so we can label that in our graph 3 1/3, which is less than 4, so that adds up. For the quantity demanded at a price of 20, we plug in, we plug into the demand curve. Okay, so in other words, we take $20 and plug it into the demand equation. Okay, and then we solve for QD. So we get 2QD equals 10. QD is dividing both sides by 2 equal to 5. So 5, which is in fact greater than our equilibrium of 4. So the size of the shortage is going to be the new quantity demanded, which is 5, minus the new quantity supplied, which is 3 1/3. So we are short by exactly 1 2/3 units. Right, so again, first we calculated the equilibrium price and quantity, and then we said, well, if the price is not at the equilibrium, if it's actually lower, well, we know that consumers like lower prices, and we see that here they start buying more. And producers don't like lower prices, so we see that here they produce less. And the result is a gap between supply and demand, a shortage equal to 1 2/3 units.